Welcome back, physics fans. This is just a little checkup on graphing in kinematics, a review of the first three, and then we'll just go over the fourth one and how I do it in my class. Here we go. The four rules are there on page 4 in your package. The slope of a displacement time graph is equal to the velocity. So if we have a position time graph or a displacement time graph, this is just a review, and there's a line on it, a position time graph. The slope of that, the slope gives us the velocity. Okay, that's rule 1. Rule 2, if we have a velocity time graph, the slope of this gives us the acceleration. Okay, that's rule number 2, the slope of it. And rule number 3, the area. So the area, I'm going to do it in two different colors here because I'm going to split it up into a triangle and a rectangle, yellow rectangle and a green triangle. Okay, and the area of this would be 1/2 base times height, and then the area of this would be just base times height, this height here for that, and for the triangle, the height of that. And you'd get these areas and we'd add them together and we'd get the total area. And the area is the change in displacement. The area under a velocity time graph is the change in displacement. Okay, that's good. Now the new one is the area under the acceleration time graph is equal to the change in velocity. So we're going to go over that right now. So there's two slope formulas, two slope ones and two area ones. And the velocity time graph is used for both. Pretty cool, pretty good stuff. Okay, let's just get into our lesson 7, our last one here for this chapter, and it's on graphing and it's on acceleration. If you're given an acceleration time graph, you can get the change in velocity by calculating the area under the graph. This is going to go real quick now. The horizontal line here, okay, starts at 2 seconds and ends at 7 seconds. So this time frame here, it has a 5, and it's rated up at 40, whatever the units are. Okay. And then, so the area here, represented by the little crosshatch blues, is equal to the change in velocity. So this is 40. So we'll do it out here. Area is equal to base times height, and that's equal to 5 times 40. If you even did the units in here, this is 5 seconds. And the units are meters per second. And when you multiply it out, you'll see that the seconds actually cancel because this one's in the denominator and you get meters. And that'll be 200. Now that's saying that the change in velocity is 200. So if you accelerate at 40 for 5 seconds, that change in velocity is that. How would it look on the velocity time graph? Well, that means the height, the change that the velocity is going through, it would be 200. Where? We don't know. It could be down here, up 200, or up 200 here, or wherever. It could be somewhere else, but we know the change is 200. Okay, how do we use that when we're doing questions like A? Now, I'm going to do it all here and show you how to do it, but on the next page, it's all explained. So everything I'm going to do here is already explained, so you don't have to take the notes here. Just watch this, and then you can watch it, look at it. This is a time frame of 6. This is a height of 5. So the area of this is equal to base. Oh my goodness. Let's just erase that and start again. Here we go. I'm going too fast, too excited. Here we go. Area is equal to base times height. That's 6 times 5, which is equal to 30. Now that means the change in velocity is 30 because the area is 30. Okay? That means the velocity change from the bottom of the red to the top of the red. That is 30. Not all the way from the black line, but from where it began at 15 and goes up 30. That means this velocity, the final velocity, is equal to 45. 15 plus 30. Okay, that's one of the answers that we have to find out, because it said find out B and find out P. Well, I found out B. Now that's an easy one. Easier than this. This other part, we have to find the area underneath the velocity time graph. And there are two different things here. We have this triangle. Okay, so let's do it in a green triangle and the yellow rectangle. Okay, so the green triangle, let's just do it over here, is 1/2 base times height, and that height is already known. We know it because that's this 30, this 30, this 30, this 30. That's the height of that triangle. And the base is still the 6 seconds all the way along. 6, and that's 6 as well. So we have 1/2 6 times 30. 6 times 30 is 180 times a half is 90. And this yellow one is just base times height. And that's going to be 6 times 15, which unfortunately still equals another 90. So both of them are 90. So let's just, this is 90, and this is 90 as an area. So the total area is equal to 90 plus 90, which is equal to 180. But what is the total area? It's the change in displacement. So that means that's how much displacement changed. And here the position started at 3, and it went up 180. So that means this position here is 183. Okay, pause it and try reading through it if you didn't follow it, and then try B, and then check to see if my answers for B are what you got. Did you pause it? Pause it. Did you get that this area right here underneath the acceleration time graph is a height of 3, base of 8? So it's 24, and that's the change in velocity, and that means this green triangle over here has a height of 24. Okay, let's see. Part of this you can do. Okay, so the height of this is 24, and the base of this is 8, so we need to do a little triangle here, and this is 1/2 base times height is the area, and that's going to be 1/2 8 times 24, and that's going to equal 96. So this is 96, and if this is 24, and it ended up at 30, then the initial here had to be 6. So that's important. That's one of the answers. B is equal to 6. We had to figure out B, and now we have to find out P is over there. So that 6 also tells us the height of this, and this is 48. And so here we go. This area is 48, and this is 96. Together, the area, the total area, is 96 plus 48, which equals 144, and that's the change in displacement. So that means this displacement over here went up 144. So this position is 147, and that's the other answer. Okay, thanks for paying attention. Good luck on finding some of the answers down below. I will put the answers somewhere. And here we go. There's the answers for C. I just might as well scroll through these. Right? C is negative 34 at 60.5. And there's D and E. And here's F and G. H, you actually have to draw what that graph looks like too, because I had to fix it. Anyhow, there you go. That's good for the review. And for the fun of it, let's just go all the way down to the bottom and put the answers up for that chart. So those are the answers for the chart. Now that you're checking it, yay, you're ahead of the game. Thanks for paying attention. Enjoy.